Assalamualaikum. So today in BM continue for number 8 question. The belt in figure 1.3 steady velocity which is in linear form 2.5 meter per second, and the skim at the top of the tank of aerodynamic viscosity is 0.29 kg per meter second. Distance between roller, which is L, it is 2 meter, and wide of it there will be 16, and depth of oil, which is H, 3 centimeter. Assume the linear velocity profile in the oil. Determine the resisting force exerted by the belt. So we're going to use the new to shearing stress relationship equation, and we're going to arrange this formula into this form. So new, there will be 0.29 times by the effecting area for shearing stress in fluid, which is at the surface of the belt that make contact into the oil. So the area that will be 2 times by 0.09, 0.06 times by the velocity 2.5 divided by the height, which is the distance from velocity 0 to the target analysis point. Thus make the H into 0.03 in SI unit. We'll get the force will be 29 Newton. Question B, the power required to drive the belt. So this is the relationship between power and torque. So the upper side you can neglect. It just include the torque value, which is 29. We know that the relationship between linear velocity and angular velocity is V equal to omega R. Omega must be in rate per second, and thus omega is equal to V over by R. Rearrange this equation. We know that the torque is equal to force times by distance. In this case, force times by the radius of this circular shape. Using the relationship between T omega and the FR formula right here, which is just substitute the FR value into T, and substitute this equation into T omega. You can cancel out the value of R. Thus we'll leave out with P equal to F times by the linear. There is the linear velocity. You need to take note about it, and you get 72.5 watt. So just take note, V in here refer to linear velocity, and omega in here refer to angular velocity. In every calculation, especially in using this equation, you need to use omega in rate per second instead of revolution per minute. If you've been given RPM, you need to convert into rate per second first. For example, in this video of question 4, I have make a I teach you a method how to convert revolution into linear velocity or into rate per second, which is in this work right here. You can follow this work. If you've been given RPM, you can use this method to convert into rate per second. So I think that's all for today. Thank you for watching and have a nice day. Bye bye.